Hello, pre-calculus. So, for the end of your semester, I decided what I was going to do is go through the midterm in detail and work through the solutions in this video for you so that you can use it to review for the final. I'm going to do this video and then I'm going to do a final study guide where I'm going to work through some sample problems that you might expect to see on the final. And that way you guys can study a little bit and see how you feel. And you've learned a lot this semester, and I want to just stress that you can do this. All you have to do now is kind of show me what you know. And if you can do everything in this video and in the second video, you're in a good position for the final. So here is problem 1 from our midterm. It seems like so long ago when we were talking about lines. Problem 1 says, write the equation of a line that is parallel to y is equal to 1/2 x plus 17, and it passes through this point -4, -9. So what this problem is asking you to remember is, what does it mean for two lines to be parallel? Lines that are parallel have the same slope. And so what this problem is asking you is to write a line that passes through this point and has the same slope as this line. So what we can do is we can use the point slope equation to do that. Here is our point slope equation. It says y minus y1 is equal to m times x minus x1. And here our slope is m. And this y1, x1 comes from this point here. So I'm going to plug those in. So we have y subtract -9 is equal to 1/2 times x subtract -4. So we end up with y plus 9 is equal to 1/2 x plus 4. One thing I might ask you to do on the final exam is to write this in slope-intercept form. So this is point-slope form. If we want to write it in slope-intercept form, all we have to do is solve for y. So let's go ahead and do that. I'll start by distributing my 1/2 here. So I get y plus 9 is equal to 1/2 x plus 2. And I'll subtract 9 from each side. And I get y is equal to 1/2 x minus 7. And that could be a beautiful final answer for that problem. So there's problem 1. Let's take a look at problem 2. All right, so I give you a quadratic equation, and I tell you without using Desmos or a graphing calculator, I want you to find the x-intercept, the y-intercept, the vertex. And then I also want you to tell me, is it a maximum or minimum value? And I want you to find for me the axis of symmetry. So we can go ahead and basically this problem, if you can do this problem, you can graph any old parabola, which is kind of nice. So let's go ahead and do that. Here's the equation we're working with. We have 1/4 x squared minus 2x plus 6. So let's work on problem 2. We have 1/4 x squared minus 2x plus 6. So let's start by finding our x and y intercepts. So we can find our y-intercept by setting this function, by plugging in, we set x is equal to 0, and we solve for y. So that will look like this. We'll say 1/4 times 0 squared minus 2 times 0 plus 6, and that's going to equal our y value. So we get 0 minus 0 plus 6 is equal to our y value. 6 is equal to y. So our y-intercept here will be the point 0, 6. For our x-intercept, we want to use the quadratic equation. So we have 1/4 x squared minus 2x plus 6. And that's in our standard form, ax squared plus bx plus c. So what I have here is that 1/4 is my a, -2 is my b, and positive 6 is my c value. So here's how I'm going to find this. I'm going to use my quadratic equation. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So all I have to do is substitute in the values where I see them. So the c value of 6 will go here. The b value of -2 will go in here and here. And the a value of 1/4 will go in here and here. So I'm going to substitute that in. And I encourage you guys to work along with me on this video. So we have -2 plus or minus the square root of -2 squared minus 4 times 1/4 times 6, all divided by 2 times 1/4. And now we just have to simplify what we have here. I'm going to go step by step. So here I have -2. That becomes +2. Plus or minus the square root. -2 squared becomes 4. Then I have -4 times 1/4 times 6. That becomes -6. All divided by 2 times 1/4 gives me 1/2. Don't overthink your fractions. Think about money. If you have 2 quarters, you have a $0.50, right? 2 quarters makes a half. If you have 2 quarters of a pizza, you have a half a pizza. Try to visualize things like that to help you along. Now at this stage, you might start to worry because take a look at our discriminant. Remember that the discriminant is underneath the radical of the quadratic equation. And what I have here is a negative value. 2 plus or minus the square root of -2 divided by 1/2. So if I were just solving a quadratic equation, I would say this is an imaginary root, and I could keep solving. But what I'm looking for is actually, I'm looking for an x-intercept. And what that means is an x-intercept would be where a parabola crosses my x-axis, those 2 points right there. So one thing about the x-axis is that the x-axis has no imaginary numbers. And because we see that our quadratic, our roots are imaginary, we have no x-intercepts. And that can mean our parabola looks a couple of different ways. I could have the parabola above the x-axis like this. Or I could have the parabola below the x-axis like this. And either way, notice how I'm not touching the x-axis at any point. So the answer I was looking for here from you guys was I wanted to see some of this work, and I wanted you to tell me no x-intercepts. All right, so that's our x and y intercepts. We wanted to find our vertex as well. So again, our equation is 1/4 x squared minus 2x plus 6. And we have an equation that can help us do this because we're in this form. We have an equation, negative b over 2a. And then if we plug that into our function, we'll get the y coordinate out. So again, this is about identifying our b's. Our b is negative 2. Our a is 1/4. So we're going to plug that in. Going to have negative 2 divided by 2 times 1/4. And so that's going to give us 2. The negative times the negative becomes positive. And then 2 times 1/4 gives us 1/2. And we can further simplify this as saying 2 divided by 1/2, which is 2 times 2, which is 4. So our vertex is going to look like 4 as our x coordinate, and then we want to plug 4 into our function and get that y coordinate out. So here's our function, 1/4 x squared minus 2x plus 6. We're going to plug 4 in for x. So we have 1/4 times 4 squared minus 2 times 4 plus 6. So that gives us 1/4 16 times 16 minus 8 plus 6. And that gives us 4 minus 8 plus 6, which gives us negative 4 plus 6, which gives us 2 as our y coordinate. So our vertex is the point 4, 2. And that's how you find the vertex of the parabola. So now, actually, we could kind of graph it. We know a little bit about it. But I asked you another question about this. I wanted you to find the axis of symmetry. And remember that when I have this beautiful parabola shape, the axis of symmetry is a line that cuts it right in half going through the vertex. So now we know our vertex, that's this point right here, is 4, 2. So what we really want is the equation of this line, which is a vertical line passing through x is equal to 4. So our equation for the axis of symmetry is x is equal to 4. And I also asked us to state if the vertex is a maximum or a minimum. Or min. So if your parabola opens up, then the vertex is the lowest point on your parabola. If your vertex opens down, then your vertex is the highest point on the parabola. So in other words, if I have a maximum vertex, that means my parabola opens down. If I have a minimum for a vertex, that means my parabola opens up. So this question's really asking you, does this parabola open up or down? And we can check that by looking at the equation. The coefficient before our x squared term tells us whether our parabola opens up or down. So if that is a positive number, if that's a positive number, our parabola opens up. And if that's a negative number, our parabola opens down. So because 1/4 is positive, we know that our parabola opens up, which means we have a minimum value. And that's everything about the parabola. So that was our second problem. And I'm explaining more than I would expect you to have explained on the exam. I'm doing that so that you can learn something while you're studying. Okay, if you just wrote, it's a minimum, I will give you credit for that answer. I know you guys know how to do it and how to figure it out. The next problem is problem 3. I ask you to determine the roots in the end behavior of the polynomial f of x is x minus 2 quantity squared multiplied by x minus 1. I wanted you to tell me something about this because I know that you could use Desmos or a graphing calculator to find this exactly. But what I wanted to check was your mental understanding of why that's the case. So I did want a little bit of explanation for this one. And I'll show you kind of how we could figure this out. So there are a few things to look at here. So this is for problem 3. We had f of x is x minus 2 squared times x minus 1. And I wanted to know the x-intercepts, and I wanted to know the end behavior. So to find the x-intercepts, we can set this equation equal to 0. X minus 2 squared times x minus 1 is equal to 0. So that means x minus 2 squared is equal to 0, or x minus 1 is equal to 0. So x could be 1, or x could be 2. So these are our x-intercepts. If you write them as points, those are the points 2, 0, and the point 1, 0. So those are our x-intercepts. I also wanted you to tell me about the end behavior. There are a few different things to know about the end behavior of a graph. So we can have 4 possibilities. And I drew this picture in class. So I'm going to draw this again, just kind of maybe jog your memory. It might be in your notes somewhere. So I'm going to give us 4 little mini x and y axes here. Don't judge my artistic skills, and I won't judge your handwriting on the final. That's the deal. So end behavior means what is your function doing as you get really close to infinity? What does it do? So you can have a few different cases. Like a parabola that opens up would have end behavior that looks like this. Because as you go out and out towards infinity, in the x direction, as towards positive infinity and negative infinity, your parabola shoots up. A parabola that opens down could have this kind of behavior. You could also have, I don't know if you guys remember the shape of your cubic graph, which is kind of like that funky little S. That's another type of end behavior that you have. So you can have one that opens and looks like that, like the little picture we just drew. So one side of the graph shoots down towards negative infinity and one side shoots up towards positive infinity. You can have it the other way around. So these are the 4 kind of things that your graph can look like. And I compared it to a parabola for a good reason. So these top 2 cases, you have an even degree polynomial. These bottom 2 cases, you have an odd degree polynomial. So when I ask you about the end behavior, I'm asking you about the degree of the polynomial. So let's take a look. This is our polynomial in question, and we want to know the degree. When a polynomial is written like this into a fully factored form, you can find the degree by adding the exponents of each factor together. So there's an invisible 1 here that we don't usually write. So the degree of this polynomial is 2 plus 1, or 3. So that's an odd number. That means we're going to have one of these 2 pictures. But which one? How can we tell? So the picture on the left happens when the leading coefficient is positive. And the picture on the right happens when the leading coefficient is negative. So this is a question now about our leading coefficient. So the leading coefficient would be the coefficient on your first term involving your x third term. And if I look closely at this, I don't even have to multiply these two together to see what my leading coefficient will be. I can focus in and look at this leading term here. That's a positive value. That's a positive value. When I multiply two positives together, my result will be positive. So I know this leading coefficient will be positive. So that means I've narrowed it down. This is the end behavior of the graph. And if you drew a picture like that, I gave you a little bit of credit. But there is some math vocabulary and communication that is important that I wanted you to use here. So you got a little credit if you drew me a picture like that. You said, Sarah, this is my end behavior. And you're right, and I know what you mean. But the best notation for something like this would be to say, as x approaches positive infinity, f of x approaches positive infinity. And what that means, if you look at this little picture, is that as I go out on my x-axis farther and farther in the positive direction, my arrow, my y direction, is also moving up. So, as x is approaching infinity, right, my y value, my arrow, is going up. It's also approaching positive infinity. So you can say that. You also have to tell me what's happening in the negative direction. So I want you to tell me as x is approaching negative infinity. That would represent the other side of our graph, the negative direction. So as I'm approaching negative infinity, what's the function doing? What's the y value doing as x approaches negative infinity? Our arrow here is pointing down. So as x is approaching negative infinity, our arrow, our y value, is going down. That's approaching negative infinity. So f of x is approaching negative infinity. This was the notation I was looking for. If you wrote this, I give you a lot of credit. If you wrote this, I know what you mean. If you wrote this, everyone knows what you mean. That's why it's worth more points. And that's all there is about that problem. All right, let's talk about the domain for this rational function. This one was a little tough for some of you, and that's okay. We'll figure it out. So the domain of this function, we have a rational function, which the rational function, giving it that name, is telling us that there's a fraction involved here. So we have x plus 6 in the numerator, and then x squared plus 12x plus 20 in the denominator. So let's go ahead and do a little bit of work with that and see if we can figure out what the domain is. I sense my dog is about to start barking. He doesn't like the rational functions any more than you guys do. So we have f of x is equal to x plus 6 divided by x squared. Oh, I already forgot what the problem was. This is why I have you guys write the problem down. It's hard for me to remember these things. I'm an old lady now. X squared plus 12x plus 20. I apologize for scrolling so much. I know it's difficult for you guys. X squared plus 12x plus 20. Phew. That was my brain workout for today. So we want to find the domain. So one way I remember this is I remember that the domain, that's associated with the x value. The inputs of my function. And when I look at this, I already, with my mathematician's eye, I have a fear. And my fear is dividing by 0. Anything I divide by 0 causes me a problem in mathematics. So the domain of this function, any number I put in, I cannot divide by 0. So what I'm really saying when I'm saying find the domain is I'm saying make sure that x squared plus 12x plus 20 cannot be equal to 0. Cannot be equal to 0. So let's figure out what x values are going to cause a problem for us here. I think we can figure this one out by factoring. I'm going to list my factors of 20. 2 and 10. 3 doesn't work. 4 and 5. Oh, it doesn't factor? Oh, what a mean teacher. What a mean teacher. Plus 12x plus 20. So I see here that I'm not going to be able to factor to solve, which means I'm going to use the quadratic formula. That's okay. We can do that. Oh, wait, guys. 2 plus 10 equals 12. I was so hung up on the fact that 4 plus 5 doesn't equal 12 that I was completely overlooking that factor. Oy, oy, oy. I'm glad you guys took the test and not me. All right, but it's nice that this factors. I'm not as mean as I thought I was. I was like, really? So here we have our factors. So this actually breaks down to saying x plus 2 times x plus 10 should not be equal to 0, which means if x plus 2 should not be equal to 0, and x plus 10 should not be equal to 0. So x should not be -2, and x should not be -10. And the reason why is that if I plug in -2 into my function, if I say x is equal to -2, all of a sudden I'm going to be dividing by 0. You can check that and verify that. So we want to make sure that we don't divide by 0. So these two x values cannot be in our domain. -2 and -10 are not in our domain. And if you found some way to communicate that to me, I gave you partial credit. But let me show you what I wanted the best way. So if you said something along these lines, -2 and -10 are not in our domain. Maybe you told me x is not equal to -2 or -10. Maybe you said x is anything except -2, -10. Those were all partial credit answers. I gave you some points for that. But let me show you what I gave you the most points for, which is, of course, interval notation. So if you told me the domain of this function was -infinity all the way up to -10, union, -10 all the way to -2, union, -2 to positive infinity. This was worth full points. This is communicating the same idea, but it's in standard mathematical notation. So what this means, these parentheses mean don't include that number. Don't include that number. That number's not in the domain. So infinity and negative infinity are not included because you can never reach infinity. No matter how hard you try, there's always farther you can go, just like anything in life, all right? There's always more to learn and more to do. You can't touch negative infinity or infinity, so therefore you cannot use a bracket there. But here around -10, this is saying -10's not in our domain. -10's not in our domain. -2 is not in our domain. That's what the parentheses are signifying. They're telling you those numbers are not in your domain. What the interval is telling you, I know this is tough because it looks a lot like the coordinates for a point. Students get these two notations mixed up. But what this really means is every number from all the way as far as you can go in the negative infinity direction, counting up to -10. So it means every number in between negative infinity and -10. This here means every number in between -10 and -2. This means every number in between -2 and positive infinity, as high as you'd like to go. And that's our domain for this function. So the real trick is to find what's not in your domain and take it out. There we are. We're getting so close, you guys. We're almost done. All right. The next I say I wanted you to, for problem 5, we're halfway there and I said we're almost done. I don't know if that's silly for you guys, but I feel like we're almost done at this point. So problem 5, I ask you guys to write the equation of graph that has a shape of y is equal to the square root of x, that has been reflected across the y-axis and shifted down by 2 units. So we want to reflect across the y, we want to shift down by 2 units. So let's kind of figure that out. Let's figure that out. This is problem 5. Y is equal to the square root of x, and I want to reflect across y, and I want to shift down by 2. So I'm not going to draw the full graph by plotting points or anything, but I am going to do a little sketch just to make sure I know what I'm trying to do here. So I know my graph looks kind of like that. That's the basic shape that I have for y is equal to the square root of x. And what I want to do is I want to reflect it across the y-axis. So here's my y-axis. So I want to reflect it across the y-axis and bring it over here. And then I want to shift it down by 2 units. So I want to pull the whole thing down by 2 units. Let's do that in red. I want to shift the whole thing down by 2 units and then have it look kind of like that. So this little red graph would be like my final answer that I want to have. Something that looks a little bit like that. So what I need to think about is what transformations will accomplish this. I think a lot of us feel like the shifting down by 2 is easier. Y is equal to the square root of x. And if I subtract 2 out here, I know that's going to shift down by 2. And that's true. But what causes a reflection across the y-axis is when you make the argument of your function negative. So you want to have y is equal to the square root of negative x, and then outside of your function operator, subtract by 2. And this would be the correct equation. You can check it on Desmos if you're curious. And at this point, I feel compelled to let you know that you will see some of these problems on the final, and I will change some of the details. So for a problem like this, I might ask you about different transformations. I might ask you about a different function. So if you feel like this problem, if you feel like you only understand this function or those transformations, take a look at your notes. See what else is out there. Problem 7. I asked you to sketch the graph of f of x is 2 to the x and label for me 2 points. And I'll show you 2 points that are good to do, and we'll sketch that graph. So we want to do 2 to the x. So here we have f of x is 2 to the x. So I'm going to get a couple points. One thing that's nice about a graph like this, I told you guys only to give me 2 points and that would be okay. But I'm going to put in 3 or 4 just so that we can make sure we have the right shape of the graph. So some values I'm going to choose. I'm going to choose x is equal to 0, x is equal to 1, x is equal to 2, and x is equal to 3. So if I take 2 to the 0, that gives me 1. 2 to the first, that gives me 2. 2 squared, that gives me 4. And 2 cubed, that gives me 8. So the points I have that I'm going to plot on my graph are the points 0, 1, 1, 2, 2, 4, and 3, 8. So let's set up a beautiful graph here and we'll plot those points. Because I only have positive values. I'm only going to sketch the first quadrant here. So here we have the point 0, 1. Here we have the point, and notice I gave myself a little tail off into the second quadrant. You'll see why. And then I have the point 1, 2, and the point 2, 4, and the point 3, 5, 6, 7, 8. Counting my boxes here. And this is going to give me the basic shape of my graph. We'll do it in green. So notice my graph is increasing exponentially. This is an exponential function. And the other side of my graph, down like so. So remember that exponential graphs have an asymptote at x is equal to 0. I'm sorry, at y is equal to 0. And then I wanted you to label 2 points. And so all I meant by that was tell me, hey, this is the point 3, 8. This is the point 2, 4. You could label any of those points for me. And that's what the graph looks like there. You can check that on Desmos as well, if you don't believe me. We all know I've made mistakes before. Problem 8 asks you to convert the exponential into logarithmic form. So I gave you 4 to the v power is equal to a. And I wanted you to write that as a logarithm for me. And so let's take that and see what we can do there. So we have 4 to the power v is equal to a. To the power v is equal to a. Let me show you how I like to do this. I like to treat it as a little equation. It makes it easier for me. You can do this another way and still get the right answer. What I do is I'm going to take a log base 4 of each side and use my log properties. So on the left-hand side of my equation, my base of my logarithm and the base of my exponent are the same, which means those cancel out, and I'm left with v is equal to log base 4 of a. And this is actually logarithmic form. We've achieved logarithmic form. This would be a perfectly acceptable answer here. You would be good to go. The trick with this problem is if you remember the logarithm properties, it's not so difficult and it's pretty straightforward. But if you don't remember them, if you're not sure what the problem's asking you to do, it's really difficult to figure it out. This is one of those ones where if you know some facts and you know the right notation, it's not tough. But if you're kind of shady on those facts, if you're not sure, then it's a pretty tough problem to attempt. So if you're not sure the step I took there, make sure to review in your notes, take a look at the section on logarithms again. Problem 9, I'm asking you to evaluate log base 1/2 of 16 without using a calculator and explain your work. The explaining your work here is crucial because I know that some of you have calculators that will just do this work for you. And so asking you to explain your work is a way for me to make sure that you're doing it without a calculator or that you understand how to do it without a calculator, which is what I'm really looking for here. So log base 1/2 of 16 without using a calculator. And because you had to explain your work, I'll explain my work too. How's that? So here we have log base 1/2 of 16. And we want to know what is that equal to. So central to this is to remember what the logarithm is asking. So this means that I have this means 1/2 raised to some power is 16. What is that power? That's what this is asking you. 1/2 to some power is equal to 16. So here's how I'm going to figure it out. I'm going to use my properties of exponents. and write 1/2 is 2 to the negative 1 is equal to 16. And then I need to figure out what goes here. There's some question mark power that will go here that will make this work out and make that equal to 16. 16 is a power of 2. So I can rewrite that. I can say 2 to the negative 1, all raised to something, should be equal to 2 to the 4th power. 16 is equivalent to 2 to the 4th power. That's where I got this from. So now I'm going to use my power to a power rule and realize that this means negative 1/2, or negative 1, sorry. Negative 1 times something has to be equal to 4. What would make this statement true? Well, if that thing right there was negative 4. Now, I used question marks all throughout this because you guys don't like variables. But the question mark here is just a variable. I'm saying that is equal to negative 4. So the answer to this problem, log base 1/2 of 16 is equal to negative 4. And that would be sufficient. If you showed me some work like this, that would count as an explanation. If you told me something like this, that would count as an explanation. Basically, if you told me anything that let me understand your thinking and what I understood from your thinking made mathematical sense to me, I gave you points for this problem. If you didn't write any explanation, I could not give you any points because I did not understand what you were thinking. So I tried to be expansive here and put on my understanding thinking cap so that I would really be able to connect with what you were trying to tell me. And for the most part, you guys told me really great stuff, and I was very happy. Most people who wrote down some kind of explanation got credit for this. Problem 10. This was a widowmaker. Okay, I know this was the toughest problem on the exam, and I just wanted to let you know you will see this on the final. You will see a problem exactly like this on the final. I might use different numbers, but you're going to have to do it. Okay, so make sure that you know that's on there. The reason I'm doing that is because so many of us missed it on the midterm. I want to give you a second chance to do this and to show me that you understand it so that you can take that knowledge with you into calculus and be ready, okay? So we have 4 raised to the 6x minus 6 is equal to 42. This is a problem involving logarithms and logarithmic properties. Oops. And that's how we're going to need to solve it. So make sure you've got your logarithm properties still in your notes, that you're ready to go for that. So we have 4 to the 6x minus 6 is equal to 42. There are 2 different kinds of problems when you have these exponential equations. There's 2 different ways to solve it. Some problems you can solve by finding a way, just kind of how we did in the last problem, finding a way to write this number and this number with the same base. Because if they have the same base, I can automatically set the exponents equal to each other and solve. And that's really nice. So that's what we should try to do first. I'll let you know it doesn't work in this case. It does not work in this case. But if it did, that would have been nice. And I want to show you kind of how you would know if that's going to work or not. So I would work with 4 first, because 4 is a simpler number. And I would say, well, I know 4 is 2 squared. I could think of this as 2 squared raised to the 6x minus 6. And now my task is to see, can I write 42 with a base of 2 so that they have the same? I'm not sure. 42 is an even number. So let's see. If I divide it by 2, I get 21. Oh, no. And then 21, that's 3 times 7. So I can't, this is not a power of 2. I can't write this as 2 to anything. So because I cannot match the bases, I can't use that strategy. All right, well, so now I know it's the second type of problem, which is a little bit harder, a little bit tougher. And that's okay. We can still do it. We're going to use properties of logarithms like we did in the last. What I'm going to do is I'm going to take a log base 4 of each side. There's a few ways to solve this problem, so you don't have to do exactly what I did. There's a couple of different methods. I'll show you mine, but there's more than one way to do it, and so yours might work too. So take log base 4 of each side. Then I can use my law of exponents to bring this down into the front and say, okay, I now have 6x minus 6 times log base 4 of 4 is equal to log base 4 of 42. If this step is making you upset, you got to review your logarithm properties. So if you're not clear on why I'm making this step here, why I'm making this choice, or what my justification is, that's a hint to you to review your logarithmic properties before the final. Make sure you have them in your notes and you're good to go. Now I can use another nice property, which is that the log base 4 of 4 is equal to 1. So now this is saying 6x minus 6 times 1 is equal to the log base 4 of 42. And so now what I'm saying is 6x minus 6 is equal to log base 4 of 42. Now I asked you for an exact answer, which means do not put this into your calculator. Do not use calculator. Don't do that right here. Don't use it. That's going to give you a decimal. That's not an exact answer. That was the biggest mistake I saw. All you do, so I said, you can't even read that. That says do not use calculator. Let's be a little more clear here. Do not use calculator. Don't do it. What you do instead is treat it like any other number. Don't discriminate because it doesn't look like a number you have seen before. You know that it's a number, so you can treat it like a number. You don't have to treat it differently because it looks different. That's a life lesson for all of us. 6x minus 6 is equal to log base 4 of 42, and I'm just going to treat it like a number. Like if this said equals to 7, my next move would be add 6 to both sides. 6x is equal to log base 4 of 42 plus 6. Okay. I can't add these two because they look too different. I know that this is some number. I'm just going to leave it for now. And my goal is to isolate x, so I'm going to divide both sides of this equation by 6. X is equal to log base 4 of 42 plus 6 divided by 6. This is your final exact answer. There are other ways to do this problem that would give you a slightly different answer that would be correct. So I'm evaluating that as I grade. It's one of the reasons it's taking so long for me to grade your papers. I'm sorry. And if you gave me a slightly different format for the answer, but the answer is correct, I gave you full points, obviously. You can ask me about it during my office hours if you want. So that would be your final calculator ready exact answer for this problem. So this was your midterm exam. I hope that it went well for you. If it didn't go well, that's okay. Your final exam can help make up for any mistakes that you've made here, and you have your instant replay assignment that can help make it up. So one thing I want to let you know, this exact problem, I'm going to change some of the numbers, but you'll definitely see this on the exam. So I'm going to go ahead and highlight it right up here at the top. Just so we're very clear, you will absolutely see problem 10 on the final. I will change the numbers. Change numbers. But it will be something exactly like this strategy here. I could use any of these problems for the final exam. They would be fair game. I would change the numbers. Maybe I'll change the function. So I'll go ahead and tell you what kind of changes I might make. So for problem 1, instead of saying parallel, I might say perpendicular. That might happen. For problem 2, I would just change what the quadratic looked like. So maybe it would have an x and y intercepts. So it would just have a different shape, different numbers. For problem 3, I would just change this polynomial and I would ask you to do different stuff. So remember, any of those options I gave you for problem 3, any of those different ways of writing the end behavior could be fair game. For problem 4, I would just change the rational function and the domain would be different. For problem 5, I could change the function And I could change the transformation. Oh, I skipped problem 6. I'm sorry, guys. Here I am thinking I'm all done, and I realize I didn't tell you how to find this inverse function of 4x plus 2. Let me take care of that for you in a minute. For problem 7, I would change this. I might make it something like -4 to the x power. I might transform the graph a little bit. So make sure that you're aware of how to do that. For 8, I would change, I might ask you to write this exponent in logarithmic form. I also might give you something in logarithmic form and ask you to write it for me as an exponent. So either one of those could happen. For problem 9, I'll just change what the logarithm would be. And for problem 10, I already told you it's going to be there. So make sure you study those properties and how to solve that kind of equation. Okay? That's what I'll change if I change anything when you see these problems on the final exam. So that I don't want there to be any surprises, and I want you guys to feel well rehearsed, well practiced, and just ready to go. Okay? I don't want you to be nervous on the day. But we do have to tell you how to find this inverse function. I almost forgot. I'm so sorry. Let's go ahead and take care of that. So we have 4x plus 2. There's a pretty straightforward method to how to do this. Maybe I skipped it because I find it boring as a problem. So we have f of x is equal to 4x plus 2. So what we do is we kind of rewrite it. Y is equal to 4x plus 2. We swap our x and our y values. So now we have x is equal to 4y plus 2. We solve it for y. So I'm going to subtract 2 from each side. X minus 2 is equal to 4y. And I divide both sides by 4. So this becomes 1/4 x minus 1/2 is equal to y. I write that in the nice way like you like. 1/4 x minus 1/2. And then I can change that into the notation for an inverse function, which you may or may not remember is f with a little -1 sign. That means f inverse of x is 1/4 x minus 1/2. And that would be your final answer there. This notation is important. I think I took off like half a point if you didn't do it. So make sure to do it on the final exam if it shows up, if this problem shows up. All right, now we really are done. I just want to remind you, you have way more value than any grade can ever show. Okay? You have survived a pandemic semester, your 2.5 pandemic semester, and you deserve credit, support, and to celebrate yourself for that fact, no matter what grade you get on my final exam, okay? No matter what, you deserve to be proud of yourself. And I hope you can take a deep breath, study hard, do your best, and know that no matter what happens, I've had a great class with you, and I think you're a great student and a great person. And you might say, Sarah, how can you say that to everyone on this video? Because I truly feel that way about every single one of you. All right, I'm going to cry.